So ladies and gentlemen, if we could go ahead and get started and kind of terminate those table conversations. I want to say that this is the last panel of the day, but it is by far the best looking and smartest, I think, of them all.
Bravo.
And that's...
Let's hear it.
That's saying a lot. That Paco Benitez guy put together more long words, more coherently than I've ever used in my life on that last panel. And I'm grateful. If you look around the room, this is an extraordinary group. There are the most brilliant minds in industry, in the military, and most innovative that you'll find anywhere. And it's a pleasure to be amongst you. Take a minute to say also thanks to General Dave Deptula and Doug Berkey for bringing us together as a Mitchell team. It's growing. Houston Cantwell and I were the last two hires this last summer, and it's an extraordinary group. Not just what you see up here on stage, but the folks who are filtering around in and amongst you. You couple them with the AFA folks in the back that've got the cameras, the sound. It's an extraordinary effort, and I just want to say thank you. Would you give them a quick round of applause? And so this is the final panel. I've got some notes here on the card. We're going to go through some questions, and I'll do some introductory remarks, and then we'll get to your questions just after the top of the hour. So bear with me. This is the final panel, Innovation and Delivery of Capabilities for Tomorrow's Flight Lines that will ensure that we're dominant in future conflict. We're at significant inflection points. It's just about everybody who's been up on stage today has talked about how rapidly the threat has grown and how rapidly technology is changing. You put that as an overlay over the fact that for the last almost 30 years, the Air Force has been stalled with its acquisition and fielding of new capabilities. It's time that we actually brought the two thought processes to bear and started fielding the stuff that we're developing. How are we developing requirements, working with industry partners, design, test, and field capabilities to dominate our enemies? If you look at the B-21, the CCAs, we've made some pretty big inroads, but those platforms are evolving as fast or as quickly as they're approaching the fielding elements. So it's really, it's an evolutionary process. It's clear that we can't take decades to field capabilities we needed yesterday. And with that, we're going to talk through this panel here, and I'll do some quick introductions to start the discussion. To my immediate left is Lieutenant General Dale White, Military Deputy, Office of Assistant Secretary of the Air Force for Acquisition, Technology, and Logistics. To his immediate left, Major General Solo Kunkel, Director of Force Design, Integration, and Wargaming, Deputy Chief of Staff for Air Force Futures. His immediate left, you have Brigadier General Ryan Keeney, Director for Concepts and Strategy at Air Force Futures. To his immediate left is the lovely Renee Pasman, Vice President of Integrated Systems, Lockheed Martin Skunk Works. And Chris, I'm afraid that you're last and not nearly as good looking as Renee. Chris Flynn, Vice President of Military Development Programs, Pratt and Whitney. And with that, we'll start with the first question, and I'm going to go with you, General White. I tried to lay it out in my opening remarks. It's essential that we move forward, but why, in your mind, is it essential that the Air Force drive aggressively to innovate and field a new force?
Well, I think that's not a good way to start. I think, look, first and foremost, it becomes about the threat, right? I think the threat gets a vote. We don't lose sight of that. And so I think B-21 and CCA, among other things, has taught us what is required in terms of how we acquire, and not only how we acquire, but also how we build requirements on what we acquire. And so I think as a function of time, we have to continue to build a process that allows us to not only write requirements around a force design that represents solving the operational problem, but also building an acquisition strategy and an acquisition enterprise that allows us to get those capabilities out there. And so, I mean, we could talk all day long about the why, but I think the reality is, as it always does, it comes back to the threat. It comes back to the threat and how we solve the operational problem. And we cannot lose focus of that piece. I think that's why if you reference back to the Chief's discussion this morning, you think with respect to GPC, what we're doing, the most important part of that is how we basically look at ICC and how we take that organization and make sure we have a single voice, and it's a prioritized voice in what we do and how we do it in solving the operational problem. And that voice actually represents the force design, which is largely what Major General Kunkel spends most of his time on. It is that voice that will drive the requirements, and it allows us to prioritize as well as how we approach the operational problem.
Well, fantastic. Thank you, sir. General Kunkel, understanding the capabilities that we need to have on the ramp for the next flight begins with you and your team. Walk us through how this process works, factoring in force design, mission objectives, desired effects, and the threat, and how that translates into new requirements.
JV, we just figure out what it takes to win, and then we just do that. No, the force design starts with an assessment of the strategy and the strategic environment. And my friend Trax Keeney, who's my partner in crime up in the A57, that does strategy and concepts. It might be best to start with him on just the beginning of this process, and then we can go from there into force design. You want to take that, Trax?
Yeah, absolutely. So there's a logic thread. There's a thread that runs all the way through from what has changed all the way to what we need to do. And you heard General Alvin talk a little bit earlier about what has changed in the strategic environment. And this isn't only an Air Force assessment. This is across all the joint services. But you heard some of the things. Not only is it long-range weapons, but it's the sensing ability. So air, space, that anything that is on the surface or above is seen pretty much 24/7. You tie that with autonomy for making decisions, autonomy for operating platforms, and then strike platforms that run all the way from a small UAS to cruise missiles to aircraft to large UAS to ballistic missiles to hypersonics. That means that a lot of our fixed bases that are forward are under threat. In fact, I would say in the future, as we're looking out, there's not sanctuary anywhere in the world. We are very used to sanctuary, and that's what General Alvin was talking about earlier. That's the changing character of war. There no longer is a forward base that has sanctuary where we build up the Iron Mountain, we deploy there, we start the war at the time and place of our choosing, and we end it from there. So that leads us to what's the question remains. We still need to be able to go to war, build a coalition, and end the war on our terms with allies and partners. And so what we do in concepts and strategies, we start looking at what are alternate futures, both from a capability development standpoint, which we've talked a little bit about today, and General White hit, but also different ways of operating. And eventually we snap a chalk line around what is the best fit, and that leads to force design. And I'll talk a little bit about the concept that we're talking about. General Alvin talked about it earlier today, where we talked about that high threat density environment, and that we need to be able to operate in there. Our idea is we need to operate across all threat densities, not just the places that we have sanctuary. So you need a force that is able to operate within a high threat density environment and generate combat power from there. That to block the enemy's initial objectives and to keep them from making some fait accompli. You also need to be able to operate from defendable locations and provide the jab that goes after the arm against the enemy's centers of gravity. And then at some point, when we need to end the war on our timeline, we bring in the mass of our force that is going to finish the war on our timeline. That concept of being able to operate across all of those threat densities, not just outside, not just where we have sanctuary, is what is leading to our force design.
Yeah, so, and then the force design team takes us from there, and we take a look at this, the threat density and where the threat is in the strategic environment, and then we take a look at where we have gaps, and we do a gap assessment. And, we've been looking at this problem of the increasing threat for a long time. Frankly, we've been looking at it for my entire career. When there were a few of us up in Alaska with brand new F-22s, knowing that, the plan called for us to go to base X, and we knew we were going to be threatened. We developed, a concept called Rapid Raptor, which turned into Agile Combat Employment. But what we haven't done in about 30 years is turn those concepts that Trax was talking about into a force design that defines, one, the missions that we have to do, but two, the attributes of the capabilities that we need to not only generate combat power in the air, but also to generate that combat power from the ground. So, the attributes of the capabilities to survive and generate combat power across the spectrum of threat densities, that's exactly what we're doing. And so, You know, for the first time in 30 years, we have a force design signed by the chief. And you know, I think what you're going to find is there are many places where we don't have gaps. There's many places we don't have holes. But where we do have holes, we got to fix those. We've really got to strengthen our position in this dense threat environment. You know, you heard the chief talk about it. Air power is best when it's on the attack. Air power is best when it's offensive. Air power's got to hold the knife on the enemy's throat and keep it there. We need to strengthen our position on the inside. That's exactly what we're doing. We also need to strengthen our position, you know, in this area where we can come in from afar with longer range capabilities. We need to strengthen that. Those are gaps, and those are, I think, where you're going to see the force design pointing us in the future.
Outstanding. General White, did you want to pile on there?
No, I think the key there is what Solo said, is how the force design builds the strength. Because what it's going to do, it's going to identify where those gaps are, and it allows us to prioritize what we have to do. And allows us to determine, frankly, how we're going to resource things. I think you balance that from a resourcing perspective, and then what amount of operational risk you're going to want to take in a specific area. That's critically important. You can't do that unless you have a design, unless you have a strategy, unless you have a plan. And so I think there was once a time when we could continue to acquire things, to replace things, and just continue to acquire when we had resourcing that could support that. Cold War reductions don't allow that. It requires us to make tough decisions, and to do that, you have to plan appropriately.
Yeah, so General White, I'm sorry, JV.
No, please go.
Just one more add on that. You know, you might think about this force design as, oh yeah, this is just a thing that impacts the capabilities, so we're going to see a new capability here or there, but it's much deeper than that. It goes into all of the fabric of our force, right? It goes into how we do logistics. It goes into how we do sustainment. What does a concept of combat sustainment look like? How should we be, you know, raising our people? How do we train airmen? What do we train them for? How do we organize ourselves? How do we generate readiness? And you'll see those coming up in the changes that we're making in terms of the Great Power Competition institutional commands between Air Combat Command to generate readiness. You know, Integrated Capability Command to integrate and develop those capabilities. AFMC that can come up with this concept of combat sustainment that is going to be, frankly, much different in a new force design. You know, you take a look at an Airman Development Command that can train the people so they're exactly where they need to be to slide into this new force design and actually take this, frankly, what's going to be a fantastic Air Force in the future. Now, I'll say it. We have been, those of us in this room that are still in uniform, have been the beneficiaries of the last force design, which was built in like the 1980s, right? And we took that force into war for the last 30 years, and it was fantastic. It was amazing. Those guys set us up for success. What we're doing on this stage and what we're doing in the Pentagon right now is we're looking at these future generations of airmen and going, how can we put them in the best position possible so that 30 years from now there's another, you know, General White, General Kunkel, General Keeney, Renee, et cetera, Chris, that come up here and say, yeah, we just crushed our enemies for the last 30 years. It's time to retool us.
Fantastic. Let's roll an industry into the conversation. Renee and Chris, industry's always looking at the operational environment and figuring out ways how to better meet the mission requirements. Could you walk us through what you're thinking in that regard?
Yeah, sure. So one of the key things, you know, as these force design structures, as was being talked about, are getting developed, there's obviously a lot of I'll call them, you know, DoD-specific questions that need to get answered, like training, like logistics, things like that. Where industry, I think, enjoys really strong partnership is, okay, even if there's not a set of requirements yet, because why would we need to wait for something to be dictated out, what are we seeing in terms of technology trends, in terms of investment areas, in terms of other things like that, that make sense, not just today, but also at some point in the future. So, you know, to General Kunkel's point, 30 years ago, there was a force structure design, and there were key technologies that enabled multiple things in that force structure. What are those technologies today? And also, in addition, from an industry perspective, there sometimes is a differing perspective of what technologies do we see moving forward, whether those are through our partnership with some other non-defense commercial entities or others, or our own innovation internally. It might be like, hey, you know, things like AI and autonomy, or just the power of software in general and how quickly that has in some cases overtaken the power of hardware. These are things that we can contribute, but from an industry perspective, we have to put those in context. Otherwise, it's just, here's a nice, shiny new technology. Well, what am I supposed to do with this? And so that is where we use a lot of our operational analysis in partnership with the Air Force, with a lot of the labs, the universities, and others, to be informed by that same ever-changing threat and say, okay, this is a technology that could be used in these ways, and not waiting for a set of requirements or waiting for an answer, but rather contributing to that solution with the expertise and the perspective that industry brings that is different than the perspective that the DoD writ large might bring.
Fantastic. Chris?
Okay, slightly different perspective maybe if you just step back and think about the advances that we've made in the last 30 or 40 years. In 2025, Pratt & Whitney will celebrate 100 years of propulsion innovation. 100 years of innovation, going back to 1925. And if you think about what's happened in the last 40 years, as we talked about the capabilities that we've developed, whether it's an F-16 with an F-100 with a thrust-to-weight ratio of 8-to-1 that was unheard of back in the late 70s, early 80s, to the F-22 and the F-119 with thrust vectoring supercruise, all of those requirements came down from the Air Force, and the industry team working with the Air Force delivered on those capabilities. Fast forward to the F-35, same situation. There's a threat out there, identified what the solution set is, industry brings to the table the best and the brightest workforce, the best and brightest in skilled manufacturing to deliver on these capabilities. As we look to the future, there's a lot of activity going on out there, and you guys are working on the force design and looking at a wide aperture of activity that drives a wide aperture of propulsion requirements. So I talked to my team about anywhere from 50 pounds of thrust to 50,000 pounds of thrust are being asked for to innovate to stay ahead of the threat. So as we look forward, as force design change, the sooner and the quicker we can team together to bring that capability to the warfighter, the better off the warfighter will be. So we are all in on the changing threat environment, focus on what the requirements are, and we're certainly going to deliver on that, and we're going to try to skate to the puck anticipating the future requirements like Renee talked about.
Yeah, Chris, I love that. General White, I'm going to just do a little offshoot here. If you go down the path that Chris was on, AETP, the Adapted Engine Program, was asked to deliver 4 miracles, and basically both companies delivered all 4, and yet that program was put on pause. Really critical to bring these incredible technologies and capabilities forward while they're incredible, while they're leading edge, while they're dominant. The process has to move fast. We've seen some movement with the B-21 and the CCAs, but could you talk to us about the challenges and opportunities you experience in the drive to bring those capabilities to the ramp?
Yeah, as most people know, I was a key part of the B-21 program with a huge team of people, a lot of leaders that were part of that have touched that, and then, of course, with CCA that Tim talked about earlier today. And so, hey, look, I think it's as simple as this. You use AETP as an example. I think that was a technology program. We learned a significant amount from that technology. We're continuing to learn a lot from that technology, and we're going to use that in other places. And so I don't think the idea that because it didn't fully graduate to a program of record, that necessarily makes it a negative thing. It is technology that we can use and that we are employing in other areas. And so I think that's key. And why it's key is simply this, is I think that as you look at some of the technology we have, and I'll use CCA as an example, CCA graduated from AFRL, from the S&T community, from the Skyborg program. And so what we have to do is do exactly what we did with CCA. We have to find ways where we have technologies that are born in the lab, and then we actually have it start there, we invest smartly, and then we drag those technologies into programs of record or those technologies that can actually fuel capabilities for the long term. CCA is a perfect example. Skyborg was a huge success. We had a lot of industry relationships and partnerships on that. And then once we were finished with the S&T portion, we did something unique. We did a concept refinement. And people often wonder, well, what does that mean in today's terms? And I'll tell you what it means. It's where the government and industry come together and determine what the art of the possible is. What can we actually do in the timeline that we want to do it? And so I think the key is leveraging S&T, leveraging industry IRAD as well, and then graduating some of that S&T technology into programs and giving us a head start. If every program starts as a giant EMD program, it's going to take a very long time. We have to leverage the S&T community to allow us to get a head start. I think we've done that in a few places. We're going to have to recreate that model more often.
Great.
Let me just reiterate on the Adaptive Engine Transition Program. We have taken those technologies, agreed, huge success. We demonstrated dozens of technologies that are now at the TRL level that can be put into new capabilities. We're doing that with adaptive engine technologies into the F-135 engine core upgrade. We're doing that with the next generation adaptive propulsion. So I would submit that the technology programs like those are super critical to be able to have the technologies available when you ask for them. They take a long time to deliver, and to sit and wait will be a losing proposition. So the technologies are critical, and that technology funding is super critical now for the next generation.
Fantastic, and both additive, if you'll pardon the pun, additive comments, really wonderful. Hardware is obviously a big proponent, big part of everything that we put forward, but software is a big driver as well. Modern weapon systems rely on it wholeheartedly. The quality, the agility, the security of software. You all have had incredible careers going back 15, 20, 30, 35 years. Could you talk, each of you, as you will, about what you've seen and both the capabilities and demands that we're placing on software and what we're looking forward to in the future?
Yeah, I don't think there's anyone in this room that will dispute that the future is software defined, right? I think we came from a place that was hardware defined and software enabled, and I think quickly, as a function of time, that is turning over. I think largely it's going to be software defined and hardware enabled. I think one example of that, which I think is a tremendous separation, is just the idea of, which is something we've never done, and we really have embraced this, is separate the flight safety critical and the mission system software, so that you're not locked into one place that every single time you want to make an upgrade to a capability or to a platform, you have to go off and buy another OFP. And I don't know if you know how long it takes to do an OFP. If you take the F-16, in some cases, early days, it took a year or two to actually create an OFP, an operational flight program, in terms of software. We don't have that kind of time. The threat evolves faster than that. And so I think taking that first initial step from an engineering perspective, being willing to separate and basically parse out that flight safety critical piece, and then allowing the mission systems to stand alone in such a way that you can not only integrate different capabilities, but you can also respond to the threat at a faster clip.
Yeah, I think to add on to that, I think, between Paco, Mike, Tim, and the others in the previous panel talking about, autonomy and where we're going with that's related to this software question, right? And I think, AMS, GRA, open mission systems, all those things are fantastic. When I think about this software question and, adaptability and agility, it's not just software, it's the whole system, right? It's the whole systems, it's the capabilities we need, and we need to be able to agilely develop and field these capabilities. And I'll say it here, I think the next revolution in military affairs is going to be the innovation pipeline, and how do we agilely innovate and we build capabilities that are new and we field them very quickly. An example of that would be, in the Ukraine, where they fielded the GPS artillery, and the GPS artillery was fantastic until it wasn't, and then it was a liability. And I think we're going to find capabilities like that, where this innovation pipeline, the ability to see what the enemy's doing, react to it in real time, field new capabilities, I think that's what's fundamentally different. And to do that, we need to think about structures a little bit differently. This ICC is a good step in that. I think the Integrated Development Office is a good step in that. But something else that we're looking at with the force design is how do you field Mission Area 1 capabilities, and how do you get on a continuous pipeline, an agile pipeline where you're solving for agility, where you develop something new, but actually field it quickly as well. So we're looking at what does that mean at the unit level? What does that mean at the deployable combat wing? You know, and so you'll see us, just like we have an experimental ops unit for CCAs, you're going to see us in the very near future doing the same thing for how do you agilely field new capabilities. So more to follow.
Yeah, let me follow into that real quick before you, I think the other thing is getting away. You know, I'm glad that you kind of reminded me when Paco said it earlier, the transactional nature of software, right? It's been very much integrated in as part of a platform or part of an end item. We have got to deviate from that. We have to work with industry to better define ways to basically integrate with each other. You know, things that we've never really even considered are like, you know, what software standards might look like from a government perspective. What does software quality look like? How do you bake in cyber resiliency? How do you measure those things, right? So it is truly a different world. And so to Solo's point, even Paco's point, the government has done, the Air Force has done a good job of investing in infrastructure to start that journey. We are well down that journey, but to his point, and it's very well taken, is that it's not a once and done. You have to fund the infrastructure to be able to continuously do that, to have that partnership with industry, and to be able to respond to the threat.
We'll get there.
And to build on the solving for agility, I'd say the key operational problem in the future is sustaining our kill webs and denying adversary kill webs, and those are going to be software defined in the future. Obviously, there's, as General White said, it's hardware enabling the software, but the software is the tactic, especially on a lot of autonomous systems. And so figuring out how do we stay in that innovation cycle and we keep solving for agility so that we can keep our software ahead and break those enemy kill webs is going to be a future where we're looking at software more than hardware.
So to me, one of the interesting things with software, as opposed to hardware, you know, airplanes have always had software in them. To General White's point, it was always very integrated. It wasn't a separate thing, but it was always there. But the key thing that I think software enables, especially in the last, call it 15 years or so, is that point of agility. It is faster to compile software into an end product than it is to compile a bunch of hardware into an end product. I can run my compiler overnight if I want to. It is a little bit more difficult to compile an entire airplane or an entire building overnight. What that means, though, is that change is fundamentally a part of that software. And all of a sudden, words like we have to do something quickly, the word quickly starts to mean something different in a fundamentally software-defined system as opposed to a hardware-defined system. So where does that become interesting from an industry perspective? Because there's all the technologies and everything else that we like to invest in. But it actually fundamentally changes how you have to also manage all of those technologies and everything else. So it's great to say we want to have a software-enabled system, but if my either industry or government acquisition system, is going to take 3 years to come to a conclusion on something, I may have only been able to build one prototype airplane in 3 years, but I have compiled countless versions of my autonomy product or of my software product. And so I think those are areas where that cultural change of where change isn't just a thing that happens or change is something that we try to manage and minimize because we have downstream planning that we're doing or because we made a decision 5 years ago and we don't really want to change it again or whatever else. But instead, change is something that we embrace, and we have to straddle that line between proactive opportunities and reactive of, oh my gosh, the adversary changed something, we're now going to change something very quickly just because we can. And I think that cultural change, how we manage that, how you still end up, how you take advantage of that and end up delivering key capabilities to the warfighter faster than we would have otherwise expected. That cultural element of software to me is really interesting because it impacts everything, and everything ends up having to change in order to truly unlock that capability, as opposed to just one technology or just one part of the system, because the entire system will move at the pace of the slowest item.
Great. Chris? Okay, I'm going back to your original question about what has changed. And as a young test engineer, my first day on the job, I've learned how to trim a hydromechanical control on an F-100 engine. 2 years later, the digital electronic engine control was born for the F-100. that changed the performance of the engine overnight. And it's just staggering to see what has happened since that time frame. And if you think about the F-22 and the F-119 and the capability that it brings, whether it's thrust vectoring or the integration with Renee and the Lockheed Martin team on the integration of the propulsion system, it brings the capability that we all need. Fast forward to tomorrow, and I think about artificial intelligence, and I think about not really the capability to deliver that within our electronic systems, because we'll be able to do that. The question will be, will the systems be able to handle the power and cooling that all of that artificial intelligence is going to generate? Today, every day, we're asked for more power, more cooling, more capability. And if you think about the autonomous side of this, whew, man, we're going to be asked to go even higher. So tying the software to the hardware is super important as we move forward, because the hardware's got to be able to deliver the things that allow the software to deliver their thing.
Yeah, thank you, Chris. So, ladies and gentlemen, I've got one more question left. So, if you're thinking about asking your question, just start charging that thought process. A bunch of years ago, I believe it was General Corley who said, if you're always about program next, then you may never actually have a follow-on program at all. Innovation is great, but there comes a time where you actually have to field capacity. The Air Force has struggled with that over the last 3 decades. By and large, much of that was due to budget constraints. But how do we break that trend? And how do we bring capability, capacity, and modern technology to the field as quickly as we can? And I'll open this up to the group.
I mean, I've got some thoughts on this as it relates to force design, and maybe I'll just start.
And I thought you might.
Yeah, exactly. So here's, I think we need to think about this question fundamentally differently. And I think, in the past we used to think about this, oh yeah, we just need weapon stocks, and if only we had weapon stocks. And as a captain, I always thought about, man, if only those guys up at the Pentagon could get us the AMRAAMs I need, then this dang airplane would be good, and I would be carrying A120Cs instead of A's. Come on, figure this out. I think really what we need to think about is magazine depth. And how do we achieve the required magazine depth? And then how do you achieve required magazine depth when you've got this innovation pipeline that's constantly putting out new stuff? And I mean, I've got a theory, and I think that theory is called elastic manufacturing. And I think that elastic manufacturing is you stockpile enough, a baseline for what you might need for a period of time, but then you understand what it takes to rapidly change what you are producing, and then rapidly scale what you produce, so you can produce what you need in real time. I don't think we have warehouses full of weapons and that like we've tried to do in the past. There will be some, and I think that if you guys will wait for me after the session, I'll talk you through it. Mission Area 3, I think that's stockpiling. Mission Area 1, it's not stockpiling. It's you increase magazine depth by having really scalable manufacturing capability in such a manner that you can manufacture as quickly as you're expending. I'll stop there.
Yeah, so I thought you were going to take it a different place, so I'm going to take it where I thought you were going to take it. I think that General Corley's quote is right. I think that the one difference is the threat we have now is complex. I mean, that's the bottom line. It is extremely complex. And when you think about the complexity of this threat, every single time you try to plug one hole, you find out there's another gap that exists. Whether it be from a sensing perspective, whether it be from a weapon that's not long enough, a platform that doesn't have enough range, you just continuously try to solve for agility. And so when you backstop that with the challenge of resourcing and the way recapitalization has kind of fell for us, right? When you think about the threat, you think about post-Cold War funding, and then you think about some of the programs that have slipped on top of each other from a capacity perspective in terms of production. It puts you in a very tight spot, and you quickly become to a place where you have all the production bills come due at one time. And so what it forces you to do, it forces you to reoptimize. It forces you to reoptimize. because you have to solve for agility. And the only way to do that is to be able to set some priorities. And so I think that, I hate to, I know we've talked a lot about force design, but I think that is the basis of what we have to do, is understand what our priorities are and what backstops those priorities. How do you solve for agility? How do you close the kill chain? If you can't do everything, what is it I have to do? In what areas will I take operational risk? I can arguably say, we can actually now answer some of those questions. And that's going to guide how we do things. And so I agree, we have to snap the chalk line on what those things are. We have to pursue those things ruthlessly, and then get those capabilities in the force as quickly as possible. And I assure you, from a capability capacity perspective, we also have to be concerned about the defense industrial base, the reality that is we have a strained supply chain. And so as we continue to work through some of those issues, we have to find a way to get to that capacity piece. Make the decisions, get to the capacity, and then produce the capability we need.
The force design is a coherent narrative that allows you to set the priorities.
Yeah.
And then I think from an industry perspective, one of the key things that becomes important for us is actually how we do the work, right? And so that element of solving for agility and that idea of flexible manufacturing, those are very important things that in some ways we've made some progress on in terms of being able to do. But there's technologies today that allow us to actually shorten the time significantly that it takes to build. Not just things like 3D printing, which will help, and especially when you go out to the field and you need different parts and things like that, what does that look like? But just also in our manufacturing facilities and in the software factories and everything else, of that ability to not, if you will, tool for a single product and a single schedule and a single set of requirements, but rather to enable the flexibility to say, okay, today I need this, and maybe not tomorrow, maybe it's next week, but some other time I need something different. And to have that, to be able to be that responsive is also, I think, an incumbent, or there's a requirement on industry to change how we're doing things, and to work in partnership with the government to make sure that the standards that are set and that any rules and regulations, policies that are set actually allow for that flexibility and those changes to occur, because that's how, from an industry perspective, we can actually deliver on the agility that the warfighter needs to get to some of General Kunkel's points of agile manufacturing and things like that. We can get there, I think, when we work in partnership.
But Renee, I guess one of the questions I would ask, just real quick, I think that you and I have been on this journey together. If Steve Norland were here or Steve Parker were here, I'd say the same thing. I think we've been on this journey together with some of the larger primes in terms of how do you embrace things like digital engineering, and then even some of the smaller innovative firms showing us some things about how you might employ digital engineering in a smarter way. And so I think that we're all on this journey together, but I think the fact that we're embracing it, and it's not just transactional, we are all trying to change the way we do business. That is a critical part of that. We cannot try to generate capacity the way we have in the past. We have to be more efficient, and we have to be more innovative in how we do it. And I think we're down that journey. We just have a ways to go.
I would agree that we're down that journey. I also think that there's an element of scale that becomes important, right? And there's lots of really good things that you can do and that you can show, and you can show a fancy demo or something like that. But when it comes into all of the specifics of day in and day out actually operating in that way, whether it's something as shiny as digital engineering, digital material management, and ensuring that everyone actually has access to all of the data so that smart decisions can be made regardless of who's making the decision, or something as non-interesting sounding as, well, how do we set up how our mechanics do work in more of a generalist approach, and how does that translate to the Air Force's maintainers? Those are the kind of day in, day out type of things that all have to change in order to solve for that agility element. And to General White's point, I think industry and government have been down this path and have been partnering in a lot of these areas, because that element of trust becomes really important when that change occurs. And we have, I think, a ways to go from a scaling perspective and actually doing it, in anger, if you will, with knowing that there are warfighters out there at the end point waiting for the capabilities to make sure that they can win the fight.
Fantastic.
I gotta go a couple of places here. So, raw material. Raw material. It all starts with raw material, and the raw material chain was pre-COVID and let's say, Ukraine, a worldwide supply chain. And, whether it's commercial or military, there's, so domestically sourcing titanium and rare earths, we're working on it, and the DoD's working on it. It's got to start there. We got to have the ability to produce the hardware, and so raw material supply chain super critical as we move forward into this. Skilled workforce, pre and post COVID, our workforce has completely flipped from a demographic standpoint. We have 0 to 5 year employees, almost 30 to 35%. We're training a whole new generation of propulsion experts today. We got to get that workforce educated. And then I want to just talk a second about the digital transformation that is happening. And it is happening, and on our next generation adaptive propulsion program, we've got the engineers from LCMC in our systems working through the design activity hand in hand with our engineers at Pratt & Whitney. So these things are happening, and there are bits and pieces of really significant successes. We got to pull it all together and be able to deliver at the speed of relevance that everybody talks about.
Oh, fantastic, Chris. Thank you. So we're going to turn to the audience. If you have a question, please raise your hand. It's your opportunity to kick these experts in the shins and get the answers that you want. So please raise your hand if you've got a question, and we'll get to you with a mic. Yes, sir, in the back.
Thank you. Mark Goulsbay, Shield AI. There's been a lot of talk about the importance of modeling and simulation for autonomy design and force design altogether. So my question is, what is the government doing to emulate these autonomous solutions, and how can players like Shield AI, who are solely focused on those solutions, be in that OA loop so we can refine these products together?
Yeah, I'll start, and then other folks can follow on. I think one of the things we've found specifically in the M&S aspect, and we can talk with Tim afterwards as well, is from an OA perspective, a lot of that work has to be done at a higher level, right? Because you're presenting threats that are probably coming from IC type sources, and you're delivering kind of threat capabilities. So we got to figure out a way that is more widely open to be able to allow everyone to play in the OA front. A lot of the smaller businesses over a function of time have come to me and asked, how do I get my capability in the conversation? And one of the things I always say is we have to understand operational analysis. You have to understand the operational analysis that has to be done and how your capability plays out. So that's an area where we're probably weak in bringing people on board, but an area we're very focused on figuring out how to do it. We've had a few successes. I think we'll continue to have success in this area with things like CRADAs and things of that nature that allows us to sponsor people into the OA circle. And so we're going to continue to pursue that. If you think Shield AI should be a part of that, if you're not, see me or Tim Helfrich afterwards, and we'll help on that front.
Excellent.
I think what you're talking about is decision support tools, and how do you make decisions, and how do you back up the decisions you've made with some analysis. And from a range of operational analysis all the way up through operational experimentation and the modeling and simulation of that's becoming more and more important. I think where you're seeing the Air Force make investments are in things like the joint simulator environment. I think it's been discussed a couple of different times here today. But modeling and simulation is something that's on our mind, but it's how do we rapidly evolve? How do we prove that the concepts that we're talking about, the things that we say we're going to do, the force design that we're proposing, how do we prove that it works? So, modeling and simulation has been part of us. I think we're getting even further on developing that environment that we need.
But we have to do it with industry. To your point, and I think that was the basis of your question.
Yeah, it was.
All the concept refinement we do is really largely focused on the operational assessment. What we think we can do, what we think we need to do, and where do we think we frame the requirements based on that analysis that we do, the operational analysis.
Wonderful. Any other questions? Yes, sir. JDAM, you have the floor.
That's always dangerous. Mike Dahm, Mitchell Institute. So I'm not saying this because the guy at my left here told me to say this, but effects-based operations was a thing, right? And I've heard a few times now today about this need for mass. And I would observe that mass is, you know, a hallmark of industrial age warfare. Rock'em sock'em robots. We want to vanquish our enemies and we want to destroy as many of them as we can with as much firepower as we can muster. And yet, you know, during the Gulf War, F-117s flew 2% of the sorties, but destroyed 43% of the things on the master target list. So when we do this operational analysis as we return to great power competition, I get that China is a lot bigger than, you know, a second-rate power like Iraq. But where did the need for mass come from? And is there a place in the future, not necessarily for, you know, that pristine, exquisite capability that's going to fly 2% of the sorties and destroy half the targets, but can you explain how we got back to this idea that we need to generate so much mass to vanquish our enemies as opposed to delivering discrete effects that prevent an adversary from achieving you know, their objectives? That may be wildly unpopular, so I apologize.
No, I'll start it here. I think the first thing is I would argue with your point that an F-117 going into Iraq is the same thing as going against a near-peer adversary. I think those are two different problem sets. And also, when you hear mass, I think you are hearing aluminum overcast, which is not what we're intending. It is closer to what I hear John Deptula talk about cost per effect. The issue is we need a lot of effects against a near-peer adversary. And those effects need to not only be in one domain, they need to be across domains, they need to be layered, they need to be synchronized in time as well as location. And so you need a lot more effects against a near-peer adversary than you do to hit a single target as you would in Iraq. So hopefully that clarifies a little bit of, we're not talking about just total number of airplanes. We're talking about the total number of effects that need to be able to go against higher end targets that have significant defense systems.
I think you've got that exactly right, Trex. I think it's not an either or, it's an and. You need to get the right effects, but what you can't do is while you're achieving that effect, run out of bullets while you're doing it. And, you know, I mean, even with effects-based operations, I mean, okay, let's go back to Allied Force. We're dropping GB-24s on day 1 through 15, and then on day 16, it's like, well, you guys aren't dropping GB-24s anymore, you're dropping GB-12s. Okay, and then we find out that we're dropping, you know, not paveway 2s, but paveway 1s. And then we're dropping dumb bombs that were built in 1967. So this thought that you need mass, it's not an effects-based or mass. You need both for this fight.
Great. Time for one more question if you've got it in you. Right over here.
Ladies and gentlemen, thank you. Russell Badowski, I'm an Air Force colonel, teaching over at Eisenhower right now. And my question has to do with how force design is, so you have all talked about what more we need to do. We need to do this and this, not this or this. How is the force design helping to shape the trade-offs that the Air Force is inevitably going to have to make to deliver these capabilities in a timely fashion?
Go for it, Trex. All right.
If you guys argue about it, I'll take it. I mean,
Well, I'll start, and then we'll give it to General White, who will put a finer point on it. On things. Big. That's a fantastic point, and I will tell you that it's 5.7s are notorious for saying, and I want one of those, and I want one of those, and I want one of those, and they just got a plus sign on the calculator that just keeps adding up, adding up, adding up. What I think is unique about this is the force design that we've built, and the understanding that, you know, with different threat intensity, there's probably a difference in requirements for those things, and that difference in requirements might keep you from like over-investing or overbuilding something. What you don't want to do is overbuild something where it's not needed. And I think in many ways we've done that. And you've seen that in F-22s flying over Syria. You know, dropping a JDAM on targets in Syria is complete overkill. And so this discrimination between a missionary 1, a missionary 2, a missionary 3 keeps you from having overkill where you don't need it, but understanding what the requirements are as you get closer to this high threat density. And that's the fundamental difference, is you don't just go, hey, we're going to plan for the most dangerous, we're going to build a set of capabilities that apply to the most dangerous situation, and everything else is a lesser included case. If you say that everything else is a lesser included case, what you've already done is you've built overkill in all these other situations. I'll stop there, and I don't know if General.
No,
has got
I'll
anything to
follow
add.
on a little bit. I think, I'm gonna tell you what General Slife would say if he were here with you. One of the things he would say if left to our own devices, we'll buy one airplane to replace the next airplane. We'll buy one missile to replace the next missile, one weapon to replace the next weapon. I think the force design, what it allows you to do, the first question you ask, okay, is this still an effective way to solve the operational problem? Is this still the best way to solve for agility? And so I think that's the first question you got to ask yourself when you look at the force design holistically. I think one of the things, the biggest danger, and I fear that people, when we talk about force design, we think it means requirements. It will lead to requirements. It will inform requirements, but it is not big R requirements. That's not the way it is designed to be. It's to be able to lay out what that strategy, what that high-level plan is, and then it will feed things like prioritization and resourcing and things of that, where you can make those trades, because you have the whole operational picture right in front of you, and you got to decide where you can take operational risk and where you need to fill a capability gap. And I think that's traditionally important, because now you're not in a place where, well, the F-22 is getting old, I need to get something to replace it, or the F-16 is getting old, I need to get something to replace it. It allows you to, number one, ask yourself, is new iron the best answer to solve this problem, number one? And then number two, what might those requirements be, and what does it have to do? And so we're in a much better place to do that with not only just doing the force design, but the analytical nature at which what goes into that, which is critically important. And I know Solo and his team spend an enormous amount of time on the analytical piece of this.
Oh, fantastic. And that's our time, ladies and gentlemen. Before I dismiss our panel, just want to ask you to stay in your seats. We're going to bring up General Deptula in here for some closing remarks. I do want to take a moment to say thank you. You guys were fantastic. Would you give them a round of applause? Ladies and gentlemen, the Dean of Mitchell Institute, Lieutenant General Dave Deptula.
Well, thanks, JV, and thank all of you for hanging around today. I think that you wouldn't be here if you wouldn't stuck around if you didn't think that this was worthwhile. And I think all of the panels did a magnificent job, as evidenced by the answers and discussion at this last one. A couple people I'd like to thank. First, the Chief of Staff of the Air Force, Dave Alvin, and Lieutenant General Dave Harris, and your team at A57 for basically stimulating this and making this the productive conference that it has been, because now we are all very much more informed on just what the Air Force force design is all about. Not just the presentations from A57, but everyone else who participated on the panels today. Thank you. Your panels, as well as the discussion, I think was very illuminating. Now, second, and JB, I don't know where you are, down there. You already did this, but I just want to reiterate thanks to the Mitchell Institute team, as well as the Air Force Association IT team for doing all of the things that go on behind the scenes for making this, for conducting the logistics, if you will, and making this a success that it has been. And a special shout out to Anna Marie Waldo, who's been standing here very patiently, making sure that if anything goes wrong, she corrects it on the spot. So please join me in thanking the AFA and Mitchell Institute staff. And I promise you, I won't make this long, but here are 3 key takeaways. I mean, there are many, and I'm glad that we've recorded this, and maybe we'll eke out a transcription of some of the panels. But number 1, the chief reiterated that Airpower's fundamental advantage rests with its ability to perform as an offensive force, able to put at risk what an enemy holds dear. Ladies and gentlemen, that's how we achieve deterrence and, if necessary, win if we're forced to fight. So it's also, what we learned today, a fundamental tenet of the new Air Force force design. Second, and I think this is an important point for everyone to take away as we move into an opportunity with a new administration. The Air Force doesn't just support the joint force. The Air Force is, in fact, the indispensable element of joint force operations, because there is no joint force operation that can occur without some element of the Department of the Air Force being involved. And you can't say that about any of the other services. Which takes me into point number 3. The Air Force requires an infusion of greater funding to recover from and then reverse the force structure decline that it's been in. And that's just not me. That's essentially what the Secretary of the Air Force, Mr. Kunkel, said last week when he stated that we can't afford NGAD, NGAS, and CCA without more funding. At some point, we cannot do more with less. And guess what? We passed that point a long time ago, so it's time to rebuild our Air Force, and perhaps the new administration will realize that and put the Air Force back on track to meet the demands of the national security strategy. So with that, thank you very much for your attendance. We look forward to seeing you next year, and have a great aerospace power kind of day.